In this video, we're going to talk about solving systems algebraically, and we're going to talk about solving them by substitution. Here's what you need to know before attempting this lesson. Alright, so the relationship, whenever you have an equation like 2x plus y equals 3, it's kind of telling you there's a relationship between x and y. If I change x, y is going to have to change a little bit to make the equation still the same. So there's always this relationship between x and y whenever you have an equation like this. And we're going to use this to our advantage when we're solving a system. So to solve a system, we're going to kind of force the relationship of one equation into the other equation. All right, and that'll make sure both of those relationships are true at the same time. All right, this process will be known as substitution. It sounds kind of crazy, but what we actually end up doing is not too bad. All right, so here's our example. 2x minus y equals 4, and 3x plus 2y equals 13. What I'm going to do is figure out the relationship between x and y in one of our equations. When I look at this equation, the one we're going to end up looking at is this minus y here. Why? Because there's no numbers in front of it, so it's just a little bit easier. So we're going to look at 2x minus y equals 4. Right. I'm going to solve this equation for y. So there's a bunch of different ways you can do it. I would say subtract 2 from both sides, minus 2x from both sides. And now I need to get rid of this negative, so I just multiply everything by a negative. And I get this relationship between x and y. So if I know an x value, I have to multiply by 2 and subtract it by 4 to get the y value. This is kind of telling me the relationship between x and y in one equation. But like I said, I want to take this relationship and force it into the other equation. So now that I know what y has to be equal to satisfy the first equation, I can take that and plug it into the second equation. And this is the substitution step. I'm substituting the y from one equation into the other equation. So now my equation is going to look like this, 3x. Instead of 2 times y, it's going to be 2 times the thing we know y has to be equal to satisfy the first equation. Like this. Alright, so this is the substitution. We kind of solve one equation, put it into the other one, and now we just solve this linear equation. There's only x's here, so we distribute first. All right, then our strategy for solving linear equations is to get this 8 to the other side. So 13 plus 8 is 21. And then dividing by 7 to get x all by itself. So x has to be 3 to make sure when both these equations are true at the same time. But as we've seen with our solutions for systems of equations, we need to know what x is and y is. So now we're only halfway done because we just know what x is. But we know that there's a relationship between x and y. Right. Y has to be equal to 2x minus 4, which means y has to be 2 times 3 minus 4, so 6 minus 4 is 2. All right, so I get my answer is 3, 2. All right, and let's just double check, just for this problem, just double check to make sure this actually works. If I plug 3 in, I get 6 minus 2, and that's 4. All right, so it satisfies the first one. Plug 3 in, I get 9 plus 4, 9 plus 4 is 13. All right, so this is a solution, so this did work out. It's a good thing because I'm teaching it to you. All right, but 3, 2 is a solution. We force the relationship of one equation into the other equation to figure out one variable, and then we kind of work backwards a little bit to figure out the other variable. All right, so here's the strategy written out in steps now that you've seen it once. All right, one thing you always want to do is when you're looking at a system that you're going to solve by substitution, I think about what's going to be easiest to solve for. I always pick the one with the smallest number in front because then you don't have to divide by really big numbers to solve for that equation. And we'll talk about that more with our other examples. Once you've identified what you're going to solve for, solve that equation for that variable. You're going to take that solution and plug it into the other equation. Just make sure you put it into the other one. If you put it back into the same one, nothing really happens. You're going to solve the equation you just made. That'll give you one answer. And then you go back and figure out the other answer. All right, so let's do it again. If I look at this situation, which variable makes sense to solve for, I would always just go for the one with the smallest number in front. So I'm going to solve for this 2x. So I'm going to go to the side and I'm going to do 2x plus 3y equals 4. And I'm going to get this x all by itself. So the first thing I'm going to do is subtract 3y from both sides. And then divide by 2. And again, when we're dividing, we divide everything by that number. So it's going to be just x is negative 3 over 2y. 4 divided by 2 is 2. All right, so that's the solving part. I identified what I think would be the easiest one to solve for, and I got it by itself on one side of the equal sign. Now I'm going to take that and plug it into the other equation. So now my equation is going to be 3. Instead of x has to be this relationship here, negative 3 over 2, y plus 2, plus 5y equals 5. Make sure you use parentheses whenever you plug something in, because you have to remember to distribute. This is going to be negative 9 over 2y, plus 6, plus 5y equals 5. All right, and the way I always solve equations when I see a fraction is just to get rid of it. So what I would do, again, this isn't a step you have to do, but I would do this. Multiply everything by 2, because I'm going to 2 times negative 9 over 2 just becomes negative 9. Remember to distribute, so I get plus 12 plus 10y plus 10. Oh, this should be equal sign in the middle there. And now I want to keep the y's on this side, so that's going to be a single y. Subtract the 12 to the other side, gives me minus 2. And so y is negative 2. And now I can take that answer. And remember that x has to be negative 3 over 2. Just always do that. Come on, mouse. All right, so I just put that y value I know in for the y here, so I can figure out what x is. Here the 2's are going to cancel. These negatives are also going to cancel, so I'm just going to get positive 3 plus 2 is 5. So my final answer, my x value is 5. My y value is negative 2. All right, so here's the one for you to try on your own. All right, figure out which of these variables makes sense to solve first. There's actually 2 options, I would think, and then solve this system. I'll show you the answer in 3, 2, 1. And the solution you should get is 2, negative 3. And you can see all the work here. I solved for this x. This y also makes sense to solve for. If you solve for that y, you do all the same similar steps. You just get the same answer at the end. All right, so a quick summary. You can solve a system by substitution. You do this by solving an equation for one variable and plugging that into the other equation. All right, make sure you actually go and get the entire solution at the end. And make sure you get the x and y. Don't just say like y equals 3 is the answer, because there's x and y in the system. All right. All right, I'm going to make another video about another way to solve systems, but it's not required. So if you're happy with solving every system using substitution, you don't have to watch this extra video. But if you want to see another way, I might make some problems a little bit quicker, but you can solve every system by substitution. All right, so it's not required, but if you want to have that extra thing in your toolbox, go ahead and watch that next video.